Well, maybe there's one on the top and the bottom, but they both intersect at the same spot. Someone help me. If you have a plane, if your plane is going to make a parabola, then now the plane's coming down like that, and now I guess there's just going to be an upper Dandelin sphere. So that's why a parabola only has one focus. Okay.
What about the directrix? Oh, that's just the directrix.
What is the directrix? Good question. Fu Cheng says, what's the directrix? And if we have time, we're going to get to that at the end of this unit. All right, good. What's up?
I wanted to ask this earlier. What is the relationship between eccentricity and...
That's also an excellent question. He says he wants to know, okay, now that I feel like all things have been revealed, what is eccentricity like really, like on a deep level? Good question, not answering. We only have 15 minutes left now? Really?
More like 20.
19.
How did that happen?
Wait,
It's a short period.
That's still like
Good.
no one was looking at.
All right, let's go over some homework. Woo!
Oh.
Someone should, the camera in here.
I'm going to erase this board and also the next one.
That for the camera.
Yeah.
Matthew knows how to swivel on a tripod.
That sounds like right?
I actually had time because I was home from school.
I should get paid for this.
Good. All right, let's talk about the homework. It came in various sections. Let's do a couple from like the very first section, which was like, I think it was like, do like number 6 or whatever, right? I thought this was kind of cool. Number 6 on page 362 said, graph each of the following and say what they are. X squared plus y squared equals 0. What's up with that?
Point.
Yeah, that's just a point. The only possible way to add two things and get 0, no. The only possible way to add, well, x squared is greater than or equal to 0, and y squared is greater than or equal to 0. So the only way to add them and to get 0 is if they're both 0. So the only solution to this is that x squared is 0 and y squared is 0. And so the solution to this algebraically is simply Matthew Schuster talking a unique point, the unique ordered pair 0, 0. That's like the whole solution set. So that's kind of like a circle with centered at the origin with radius 0, which is sort of what that reminds you of. Good? Degenerate circle. Good. 1 down, 3 to go. B is x squared minus y squared equals 0. What does that look like superficially? Yeah, it kind of reminds me of like hyperbola or something, right? Yeah, that's what I would think, right?
Oh, fine.
Because it's like x squared minus y squared. If it was equal to 1, it would be like a hyperbola. And in fact, it's a degenerate hyperbola. Because the only way for this to have solutions is if x squared equals y squared. And the only way for that to happen is if y equals x or y equals negative x. And so indeed, the solution to this equation is the line y equals x and the line y equals negative x. That is the solution set. Cool? Cool. Degenerate hyperbola. Good. Woo. C. Matthew, don't steal her pencil. Matthew is a pencil stealer. Let it be known. Good. Y squared equals 0. What's that?
Point.
The only way for this to be true is if y equals 0, so that's just y equals 0. So this is just a line. So this is a degenerate parabola, yeah? Okay, good. And how about part D? This one's kind of interesting. X squared plus y squared equals negative 1.
Trick question, it can't happen. Positive plus positive can't equal a negative. Right?
Good, can't say it better myself. Yeah, no solutions, impossible. Which is actually saying something kind of interesting. What does this tell me?
Radius can't be negative.
What we have seen is that every conic section is a quadratic equation in 2 variables. But not every quadratic equation in 2 variables is necessarily a conic section. That's kind of the takeaway here, I think. Because this is a quadratic equation in 2 variables, but it has no solutions. And we've seen that when you have a cone and a plane, an infinite double cone and a plane, there's always this intersection, yeah? Okay, good. All right, good. One down, all the however many parts left to go. What was the next section?
366.
366. These were just like kind of like chillish like practice problems, yeah?
Yep.
Should we do like one of them or like not even?
Not even.
I would do 13.
14 is
I can do 13. I'm going to be very casual about it, however. 3x squared plus 7y squared equals 71. Basically, Ryan, this is a crisis management situation. What do you do when numbers are ugly? You just deal with it. So I'm going to divide, stop talking, I'm going to divide both sides by 71. So then I get x squared over 71 thirds. Careful with like fractions. And then plus y squared over 71 sevenths equals 1. And so basically, what is 71 thirds-ish approximately? Like 20-something? 23-ish? 23-ish? So if that's 23-ish, what's the square root of 23-ish? Like 4.8 or something. So I'll call that x squared over 4.8 squared-ish. You guys following this? And then 71 over 70 is like 10-ish. So 3-ish. So I'll call that like 3.1 or whatever-ish. So that's all I'm gonna do. Cool, good. All right. It's an ellipse. Okay, good. Next section. Moving right along. Woo. What was the next section?
370.
370. Whatever is happening on page 370? Oh, this is also just some generic like do it problems. This was kind of just like review / practice. So we do 1?
16.
We can do 16, it's kind of cute. 16 is x squared plus y squared plus 6x plus 9. And stop talking. Initially you might be thinking, oh, it's just a circle because, you know, it must be a circle. Haha, you have been tricked because x squared plus 6x plus 9 is x plus 3 squared plus y squared equals 0. So it's kind of like a circle, but it's kind of like a circle with center at -3, 0 and radius 0. So that's the whole boom, boom, boom. Cool? Say cool.
Cool.
Okay, good. Otherwise, you guys can handle these like whole like complete the square, do it, etc. I can do one more. Good. Good. Let's do another one. What's the next section? Page 374. All right. This is a topic that I just decided was like easy enough that you could just teach it to yourself. Systems of. Is it just ugly?
Actually, it works out.
Oh, why did I assign this problem? Interesting. Okay. Whoops. Number 17. X squared minus 5y squared equals -44. And xy equals -24. Yikes. All right. First, an interlude to discuss that the curve y equals 1 over x is actually a hyperbola. Dun 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 dun. But it is a hyperbola that's like been rotated 45 degrees with respect to the x and y axes. Yeah, good. This time you should panic, Ethan. It's crazy. When you rotate axes, bad. Yeah, so now the asymptotes of the hyperbola are the axes themselves, and the vertices are like those points like 1, 1 and stuff, yeah?
Yeah.
So if that's like 1, 1, and that's like -1, -1, what do you think A is? What's A of this hyperbola? Yeah, A is now √2, because that's like that's what that distance is, right? Because if you go over 1, up 1, then you get a little square, yeah? Yeah, and so that's that. And then, yeah, B is also √2, because that's the only way for it to be like a square hyperbola. You guys following this? And a square hyperbola is one in which A and B are equal, and that has to be true, of course, because the slopes are like 1, like relatively speaking. So that whole thing's been rotated. All right, so that's just, I have not proved that this is true, but it just is true. Good. So, where was I going with that? Don't know. Okay, first we should make a rough sketch of this. let us do so. First of all, this negative is bothering me because I'm gonna divide both sides through by negative 44. So I get, I get y squared over 44 fifths minus x squared over 44. If I did that right, did I? Yeah. Equals what? So what is this? This is terrible. This is like about 9-ish. So that's more or less like 3-ish. So this is kind of like y squared over approximately 3 squared minus x squared over approximately like 6.5 or something. 6.6 or something squared. Just write 3 instead of approximately 3. So all this is doing is giving me like a rough sense of the gist of it all. This is going to, is everyone kind of cool with this? So this is going to be a vertical hyperbola with vertex about 3, and x is going to be about 6.6. So the happy box is going to look something like that. And so basically, what's my hyperbola going to look like? Something like that. That's good enough for now. I think I said like rough sketch it, right? Okay. And then we have y equals negative 24 over x. What's that going to look like? Well, that is going to be like a y equals 1 over x, except stretched out big and also like in flipped cliff formation. So I claim it's going to be like this. Okay, this picture's not like great, but it's decent enough to tell me that I am for sure going to have 2 points of intersection. Would you agree?
Yeah.
And they're going to be like one up here-ish and one over here-ish. It's a very, maybe like double-ish on that. All right, now the algebra better, is the algebra easy? No? No?
Yeah.
Kind of? The numbers work out nice or not?
Yeah.
The numbers are really good.
Yeah.
All right, so what should we do? I think we should let x be negative y over 24, right? No. Which one?
X is negative 24 over y.
Should I solve for x or solve for y?
Solve
For x. Okay, so if x is negative 24 over y, then I guess I just stick that in there and I get 576 over y squared minus 5y squared equals negative 44. And now if I multiply through by y squared, then that gives me 576 minus 5y to the 4th equals negative 44y squared. I really don't want to do this problem, but if you insist, I get 5y to the 4th minus 44y squared minus 576 equals 0. Does that like factor or no? It does?
It does.
5y plus 36 y minus 16 plus like the square.
Plus 36.
Minus 16.
Okay, good. Someone gave me a secret tip that this quartic is, which is quadratic in y squared factors, like so, and therefore this has no solutions, but this does. So my solutions are y equals plus or minus 4, and so, yeah. So now I should always list my solutions as a set of ordered pairs, and so when y is negative 4, x must be 6, yeah? And when y is 4, x must be negative 6. And that, like, roughly decent-ish kind of matches up with my picture, and so I'm happy I'm going to call it a day. Sound good?
Yeah.
Okay, good. That was very efficient. Thanks, Simon, and other people who told me what to do. Good. Is that the last section, or is there one more section? There's one more section, which is probably like the most important one. And we're going to do more problems from this page later. So page 398. Which ones did I assign?
1 that you have to write down.
35, 47, 41, 43.
1, 2, 3, 4, 5, 6. Those 6 problems. Okay, good. And what time is it? What do we have? We have 6 minutes. Perfect. Let's do 2 of the problems. Which 2 should we do? 43 and
43, 35.
35. Perfect. We do it. All right. So 35. What is good? What is 35? 35 says there's a conic whose center is -3, -2. and there's a vertex at -3, -7, and also that the eccentricity is 3/5. Well, we know enough about eccentricity to know what kind of thing is this going to be?
Ellipse.
An ellipse. Good. So we can now make a picture of this. And what does the picture look like? The center is -3, -2. Boom, boom. And if there's a vertex at -3, 1, 2, 4, 5, 6, 7. -3, -7. So already I know where the other vertex is. It's going to be 5 away, so it's going to be at like -3, 3, yeah? And the ellipse is going to be like so-ish. Alright, so basically I know that this is going to be vertical. I know that A is 5. And I know that the eccentricity, oh, this is easy, right? Because the eccentricity is C over A. So if C over A is 3/5 and A is 5, then C must be 3. And, did I screw up? No, I think it's right. So once I know that C is, stop talking over there. Once I know that A is 5 and C is 3, then I know that B has to be 4, because that's the Pythagorean relationship in an ellipse. And therefore, this looks like x plus 3 squared plus y plus 2 squared equals 1, and the x is being stretched out by a factor of 4. So that should be 16, and the y is being stretched out by a factor of 5. Good, say good.
Can you just start with the one that's bigger?
Okay, good. Last one, and then this is all we're going to do for today. Number 43 says, yo, I got a parabola. This is actually easy, but I think you just forgot about parabolas. And the focus is 2, 3, and the directrix is y equals 5. Directrix y equals 5. Okay, we can make a quick picture. If the focus is 2, 3, 1, 2, 3, and the line is y equals 5, then where is the vertex?
2, 4.
Yeah, the vertex is halfway in between. So basically, this is my parabola, right? Vertex at 2, 4, and it's upside down because duh. And so, what do we know about upside down parabolas? They are in the form y equals -4q x squared. And what is q in this case?
1.
Q is the distance from the center, from the vertex to the focus.
1.
So Q is just 1. Yep. So this is, but it's also been shifted up too. So it's like y minus 4 equals -4
X minus 2.
squared. Yeah, so that was just a parabola problem. Cool. You plot the focus, you plot the directrix, you figure out the orientation, you get the general gist first, you shift it by where the vertex is, and you know it's upside down, and you find Q, but in this case Q is just 1. Alright, good? Good, that's it. I finished class. I'm done. Say goodbye to, oh, I should collect this homework. Yeah, I will collect this homework. We will put it on the table over there where no one sits, and say goodbye to period 3. Bye, period 3.